Today's lesson is going to focus on reviewing some AZ-Merit type sample questions. On my last three videos, I talked about how to utilize the tools contained within AZ-Merit to help you answer those questions. And this one, I'm just going to go ahead and go over a few questions. So this question we have here tells us that we have a cone made of steel and another cone made out of granite. The cones are the same, have the same dimensions, but their densities are going to be different. So the density of steel is 7.75 and the density of granite is 2.75. So we need two formulas to be able to answer this question. We need to know that density is equal to an object's mass divided by its volume. And we need to know the volume of a cone, which is 1/3 pi times the radius squared times the height. So let's start by calculating the volume of a cone that has a height of 10 and a radius of 4. It's going to be equal to 1/3 pi times 4 squared times 10. When we simplify that, we're going to get 160 pi divided by 3, and that is equal to 167.47. And remember, volume is cubed, so that is in cubic centimeters. So now we're just going to go ahead and solve for the mass of each figure. So if density is equal to mass over volume, density is equal to mass over volume, I'm going to rearrange this equation, multiply both sides by volume. So mass is equal to volume times density. So we know that they both have the same volume. So for steel, density is 7.75. And for granite, the volume is 2.75. So we multiply this, we're going to get 1,297 and 89 hundredths. And if we multiply this, we're going to get 460.54. So the question is asking us for the difference between these two. So we would subtract these two. So we're going to subtract those two masses, and that's going to give us 837.35. All right, in this question, we are given the dimensions of a house, of a garage. Jeremy wants the roof to be between 3.5 and 5 feet. So that means this height right here, they show it here, but it's also can be drawn in right here. So he wants that to be between 3.5 and 5. So I'm going to use a variable other than x here. Go ahead and use h. So he wants that to be between those two values. Okay, so you can see what you have is a right angle here. We do have this entire distance, which means presumably the roof is right in the middle, so that's going to make this 15. So now we can use our tangent function because we are looking for opposite, we are given adjacent. So we want the tangent of that angle to be somewhere between, let's go ahead and solve this, but we want that height to be somewhere between 3.5 and 5. So tangent of x is equal to opposite, which we're going to call 3.5 over adjacent, or we're going to plug in 5, tangent of x is equal to 5 opposite over adjacent. So let's look at these values. We've got 3.5 divided by 15 and 5 divided by 15. So this is a larger number. So we can say tangent of x is greater than or equal to 3.5 divided by 15, but less than or equal to 5 divided by 15. And that would be this one right here. So there's a way you really could have eliminated some choices here. We know that when dealing with right triangle trigonometry, you indeed need to have a right triangle. So recognizing that this is your right triangle and that side has to be 15, not 30, you would be quickly able to eliminate this answer and this answer. And then recognizing that you're looking for opposite and you're given adjacent. So recognizing that those are the two sides you're dealing with automatically tells you tangent. So we could have eliminated that choice. All right, this question is asking us to identify the scale factor of k that's going to be used to dilate this triangle ABC. So the first thing you want to do is make certain that you know which is the preimage and which is the image. So which triangle did we start with? So this says we started with triangle ABC. So we started with a smaller one and we ended up with a bigger one. So right away we know that our scale factor is going to be greater than 1. Okay, so now let's just compare the side lengths. So this vertical distance here, we go from 0 to -4. So that's a vertical distance of 4. This vertical distance, we go from 0 to -10. So that's a distance of 10. And just for fun, we could double check these two sides as well. We go from -3 to 2, which is 5 units. And here we go from -8 to it looks like 5. So -8 to 5 would be 13, but I'm sorry, you know what? It's kind of hard to tell where that is, so yeah, we're not going to do that one. This one you can see pretty easily, but this one we can't, but that's okay. We don't really need it. So our scale factor would be equal to this ratio, 10/4, which is 2.5. And I know, since my figure is getting larger, that's how I know that the scale factor is not 4/10. All right, in problem 17, Lainey wants to calculate the height of this sculpture. So she places a mirror on the ground so that when she looks into the mirror, she sees the top of the sculpture as shown. So right here. So something we know when a light or vision is reflected, or even when you're dealing with a perfectly elliptical pool table, when this bounces off this mirror, that's going to create angles that are congruent to one another. But we don't really need that to solve this problem. So we have a right angle here and a right angle here. So these are similar triangles. So we can set up a proportion to solve for this height. So 5/h is equal to 7/28. And then we just want to solve that proportion. So 7h is equal to 5 times 28. And instead of multiplying this out, I'm just going to divide by 7 here. You know, 7 goes into 28 4 times. And that gives us a height of 20. And it's in feet, so 20 feet.